Hello, my name is Amir Hossein Jamalian. I am an electronic engineer. This session I want to talk about this new circuit. In this circuit, I used 4 different software. As you can see, PLCSIM Pneumatic version for simulation pneumatic circuits, and inputs and outputs in fluid simulator, factory I/O for simulation production lines, TIA portal for simulation PLC programming languages. As you can see, I use 2 languages in this circuit: ladder language and graph or graphset language, and PLCSIM. These software working simultaneously and they are connected together with EZOPC software. Okay, imagine the operator wants to push button S1. The condition is if this piston in the cylinder in the A0 position and the operator push the push button S1, the piston going out and after receive to the A1 sensor automatically get back and pushing down. The equation is y equal A plus A minus. Okay, let's see what we have. For input I 0.0, this is diffuse sensor. As you can see, optical diffuse sensor. This diffuse sensor excuse me, this is input section in PLC simulator. I0, I1, I2, I0, I1, I2. Okay, diffuse sensor connected to the I0. As you can see, the action in this section, and I changed the circuit because of it being more practical as my experiences, as you can see, in factory I/O. Okay, let's see from the closer view. Okay, this is diffuse sensor. I use this sensor as a push button S1 because it is more practical in this equation. This is diffuse optical sensor. As you can see, the production lines, and in the programming language, S1 as a diffuse sensor 1 working as I point 0.0. As you can see, S1 I 0.0, and this is same, S1 I 0.0. Okay, let's see. This is magnetic proximity sensor. As you can see, the sign, and connected to the I1. Okay, for better understanding, this is A0, as you can see, and this magnetic proximity sensor installed on the cylinder's shield. For example, I can describe it in this factory I/O, but you imagine this is A, the position of A0 mounted and installed this sensor, and as you can see this is activated. And the question is why? Because in the normal situation A equal or Y equal A minus, and A0 is activated. As you can see, the cylinder is inside and A0 is activated. You can see the sign A0, and in the programming language this is the green mark. A0 is activated. As you can see in the graph or graph set language too, A0 is activated. Okay, I will describe this programming language, and let's talk about another accessories. Now this is magnetic proximity sensors A1, as you can see, connected to the I2 or I0.2 for better understanding. This is input section in PLC simulator, and I2, as you can see. As you can see in this picture, A1 mounted on the cylinder's shield. When Y equal A plus and the pistons going out, this sensor activated. You will see in the action. Okay, this is A1, as I write it as I.0.2, A1 I0.2. okay, now I want to talk about output. This is inputs for fluid simulator, fluid sim. As you can see, it's vice versa. The fluid sim output working as an input and the fluid sim input working as an output. Okay, this is the solenoid valve called Y1. When the output Q0 activated, this solenoid valve action, you can see this is Y1, the pneumatic circuits. This is 5.2 directional control valve. As you can see, this is a PB normal directional valve. Flow control valves with check valves, as you can see, for control the speed of the cylinders. And this is a special pistons, as you can see, or cylinders, because I guess it's better to understand this is simultaneous. This is very similar to this piston and cylinders on the factory I/O with two shafts, as you can see, 1, 2 shafts, and this is the same in the factory I/O for more power, of course. Cylinder A, and this is pusher. I will explain it. Okay, I explained the pneumatic circuit, and I talk a little about factory I/O components in the production lines. Okay, let's see what we have. I use two pushers, as you can see in this picture, one pusher or two pushers. The pusher number 2 is for auxiliary, or for I will add it in the future. The main pusher is pusher A or cylinder A. As you can see, I used many conveyors, as you can see in this picture, main conveyor and sub conveyors. Okay, let's see what we have. This is diffuse sensor number 2. I don't use it in this programming, but it can be used in the other programming in the future. And this is pusher number 2. Okay, cylinder A or pusher number 1, cylinder B or pusher number 2, diffuse sensor DS1, as you can see, DS1, and this is DS2. I don't use it in this circuit. Okay, this is emitter, and deliver us boxes for the conveyors, and they are removers, as you can see, 1, 2, 3, 1 emitter and 3 removers. Okay, I use 2 data blocks, DB1 because I write it as a ladder languages, and DB2 or data block number 2, as you can see. For better understanding, I use 2 languages simultaneously. Popular people on the PLC programming use ladder languages. If S1 and A0 connected together, then set Y1. This is a condition as a RS flip-flop. Set Y1 as a Q0.0. This is network 1, and in the network 2, if A1 activated, reset Y1. A1, A0, and Y1, as you can see. Okay, let's talk about graph or graph set language. In graph language, I use 2 transactions, as you can see, and 2 steps. Step 1, step 2. Transaction 1, transaction 2. And this is a closed loop. When S1 passed, this is a condition for passing to the S2. If S1 and A0 activated, then going to the condition of S2 or step 2. Okay, let's see what will in this situation. I used the momentary command N, as you can see, and don't use S as a set. This is not momentary. If you use S in this condition, you must use R or reset in the other situation, but I used N as a momentary condition and Y1 connected when these conditions, diffuse sensor 1 and A0 turning on, Y turning on, and then when the A1 turning on, this is at the end of this cylinder, this is past this condition and going to step 1 as S1, as you can see in this transaction T2. It means S1 going to this situation as a closed loop, and it's an automatic circuit, as you can see. You can better understanding when I turning on the simulations, and this is the output section in the PLC simulator, as you can see Q0 or Q0.0. as you can see, this is the output Q0 connected to the Y1. This is a power supply, and okay, let's turn on the simulator for better understanding. Okay, emitter, this is the box, Okay, A plus, as you can see, A minus. This is the DS1 activated, A plus, as you can see, A minus, A plus, A minus. Okay, let's now describe this situation in this programming. Which inputs are activated? You can see the PLC simulator, excuse me. Input 1 on or I 0.5 is activated, and I1 is the A0. This is the magnetic proximity sensors at the end of the cylinders, as you can see, mounted on the cylinder shield. Okay, and this is activated in the ladder languages too, and in the graph or graph set language too. Okay, let's see step by step. Okay, I pause it because for better understanding. Now this is y equal A plus, as you can see, A plus, A plus. You can see output Q0.0 is activated and Y1 is activated. In the pneumatic circuit, you can see the ways, okay, pushing out, and this is the output for pneumatic or exhaust, as you can see. In the ladder languages, diffuse sensor 1, as you can see, detected the box at the short time, and the Y1 going to be set. When Y1 going to be set, the cylinders going out, or A plus. In the graph set language, when these conditions turning on, the program going to the next step, as you can see, this is the next step, and this step command to the Y1, this is momentary command Y1 or Q0.0, true means on. This is true means on. Okay, let's see what will happen in the next step. Okay, in the next step, when the A plus and the A1 going to be connected, A1 going to reset Q 0.0 or reset Y1. And in the graph or graph set language, when this condition turning on, the programming jumping from this step to the other step or other transactions. Okay, this is going to the other side, and in this other side I used jump command after this condition. If this condition connected, the program's jumping to the next step and going to step 1, as you can see, S1, and this is the closed loop working and working and working automatically. Okay, let's see together again. Okay, you can see this is diffuse sensor 1, I0 activated. As you can see, the lamp is turning on, the red sign is activated, and then this lamp or this diffuse sensor undetected debox, this is turning off. Okay, and this is the output Q0. As you can see, this is Q0 or Q 0.0, and turning on the Y1, as you can see, and this piston going out Y equal A plus, as you can see in the fluid sim and factory IO, and the condition in the graph set language or graph, this is true. The condition in this box working. Okay, let's see. I plus, I minus. We can see this is the cylinders going between A1 and A0. It means A1 equal 0 and A0 equal 0 too. Okay, you can see A0, I1 and A1 connected to I2. I1 and I2 are 0, and when these cylinders going to the inside, or R equal Y equal A minus, as you can see in this picture, A0 must be activated. A0 connected to the I1, and I1 must be activated. You can see I1 turning off, and this is same in the graph set language too. Okay, let's see it will happen. Okay, I1 activated, I1 activated, I1 activated. Okay, for better understanding, let's see from different views in the factory IO. Okay, A plus, A minus. You can see diffuse sensor detected the box. Okay, A plus, A minus. You can see in the ladder languages, the commands set Y1, reset Y1. Okay, let's see the graph set languages. Go to the S2, step 2, conditions, go to the S1, and the closed loop, working and working. Let's see from the other view. A plus, A minus. This is a practical circuit in the production lines, and it depends on the programmers how to use this circuit and this programming in these different sections at the factory or other places. As you can see, this is the remover removed the box, as you can see, and the emitter created the new box. New box going to the remover, and remover removed the box. You can see diffuse sensor 1 turning on, detected the box, turning off, undetected the box. Where is the this? This is diffuse sensor 1 detected, undetected. As you can see, this is DS1 detected, undetected. Okay, and in the graph set language or graph, S1 detected, undetected. Okay, A plus, A minus. Thank you very much for your attention. If you have any question, it's my pleasure to answer it. For more interest and For enthusiasts who wants to see more simulation, I suggest them to see my LinkedIn group with more than 119 simulations and pictures, of course, and in my YouTube channel you can see more than 130 simulations too. Okay, thanks for your attention and bye.